The following presentation was recorded at the 2013 SouthEast LinuxFest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information about the SouthEast LinuxFest, visit www.southeastlinuxfest.org. The SouthEast LinuxFest would like to thank the following diamond sponsors in 2013 for helping make these videos possible.
Okay, I think I'm going to go ahead and get started. Hi, my name's Joey Hess. I've been working in things related to version control for quite a long time, and what I work on tends to be things that involve not using version control for its intended purpose. So I'll actually show you just a few briefly, not that one. I used to work on putting my whole home directory in CVS, 10 plus years ago. I wrote Etsy Keeper, which lets you keep the Etsy directory in Git or something. I wrote IkiWiki, which lets you keep your wiki in Git or something. And now I'm writing git annex. So let's think about Git for a minute. How many of you folks actually use Git? Can I get a show of hands? So almost everybody. How many folks are really comfortable with it and pretty much know what blobs and trees and hashes and all that is? Not too many, that's fine. This isn't a really technical talk about Git. The main thing that I want to talk about with respect to Git is Git and large files. Now, you can check large files into Git, and by large I'm talking about megabytes, gigabytes area, or larger if you have, say, genome data or something that you'd like to manage with Git. That's crazy. You check in a large file and Git is either going to use a lot of memory, or if you have a newer version of Git or you've patched it properly, maybe it won't use a lot of memory, and then a week later you'll get a repack event and it will just thrash your disk for a month or something. I'm talking about with, say, 100 gigabytes in Git or something like that. You're not going to want to do that. So this became really apparent to me when I moved to a really remote location up in the mountains. I live in a cabin in the woods. I have dial-up internet.
Wow.
Yeah. On dial-up all the time. I have been for 7 years this decade, I think. And so when I moved out there, again, coming back on dial-up, and I was like, gosh, this is really annoying, and I have all these cat videos I want to see, and I can't manage them all. I don't know which ones are here. I don't know which ones I have to go download when I go out. I don't know which ones I've seen. It'd be great if I could just check them all into Git, and then I could say, well, pull all the cat videos, sync up, get everything. So that's when I got into this Git and large files thing. And I tried it, it didn't work, and so I sat down and made it work. I was just like, I'm going to find a way to make Git and large files coexist. And it's actually really simple how I made this work. It's all about symlinks. Now, symlinks kind of suck, but symlinks happen to be the only thing that Git conversion that isn't a file. And coincidentally, they work perfectly for what I need. So the basic idea is you have your file over there, and you want to check it into Git. You don't actually check it in. You take a hash of it. You say, okay, I have a hash. I have a key value database. I can map a hash to a file content. So I'll just check a symlink to the hash into Git, and it'll point to a directory under the .git directory, a git annex / hash, basically. And so that means that if you have the file there, you can use it just like any other file. You can move it around using git mv, whatever you like. It all just works. It also means that you can have a file that's checked into Git that isn't actually present in your local repository. So you'll have a broken symlink. And that means that you can use commands like these with my git annex program, and you can just, you start off by adding a file and committing it to like any other file, except you've used git annex add. But now you can say, well, I want to drop that file from my local repository. And it'll say, well, this is the only copy you've got of that file. So then you'll say, okay, well, I want to copy it somewhere, or maybe move it to a remote repository. Go off and shove the file around. So you're moving data around, but git annex is keeping track under the hood of where the data is and what it is, and mapping it to your files. And so you have this distributed key value store. So there's a lot of other commands that you can use, but this is basically all you need to know to use git annex, and you can probably skip 2 out of 3 of those and have it working fairly well for you. So that was nice. But then I said, well, it'd be nice if I didn't have to store these files in Git repositories out there, because that's kind of, it's okay. But GitHub doesn't let me shove a big file up into it using rsync. They don't like me to store a terabyte of data there. So maybe I'll make it so I can hook into all these different things in the cloud and support different protocols. And all I really need is the ability to put a file and get a file and delete a file and check if the file's there. REST. And so I did that. And these are the built-in protocols that git annex supports right now. The one about the web is just it can have a URL to wherever the file is on the web, and it'll say, oh, I'll go get that. I know how big it is. I know what its hash is. If it's there, great. If it's not there, well, you lost it or something. It also has these hooks. And so the hooks are a simple extension system. If you can write a 4-line shell script, you can write a git annex hook, because it's just the 4 operations. You need the commands to go get the file, put the file, delete the file, etc. And these are a few of the contributed hooks that people have come up with. Recently, a guy went on a tear and started doing a hook every day. And right around when that was happening, Flickr came out with a terabyte of storage. So he's like, well, and then the next day people were all like, well, you can actually shove stuff into EXIF data and put arbitrary files on Flickr, and now you've got a terabyte of arbitrary storage. And so he threw that into git annex, and he's doing crazy stuff with Usenet. I wouldn't recommend using all of these. Some of these are quite good. Make your own decisions. One of the nice things about git annex is that it lets you categorize these different repositories. So you can say, this repository, I don't trust it at all. If it's got the file, that's great. If it doesn't have the file, well, one of the other repositories will, because I don't trust it, so it's probably gonna be on my offline archive disk or something. At least I can get back to it if Flickr says, no, actually, that EXIF data is easy to detect, and wham, it's not, your files are gone. Some of the other ones, like the Internet Archive, I think are, great things. Actually, that's just a simple application of the S3 that's built into git annex, but, and I don't know about Mega and some of the other ones. I haven't even tried half of these things. So, I should mention that all this data that's being sent up to these various cloud providers is encrypted pretty much by default. You have to say whether you want encryption or not, and all you need to say is encrypt it to my GPG key, or encrypt it to a shared key that's stored in the Git repository, because I don't want to do key distribution. I actually use an encryption scheme developed for the Obnam backup program by Lars Rosenius, which has been vetted by a few people like Daniel Kahn-Gilmore who know their stuff about encryption, so I'm not just making this up. And it is just using basically GPG, but it's like a layer on top of GPG. So if you want to share your encrypted repository with somebody else who doesn't have your GPG key, you can just say, well, add their key. And all of a sudden they can access all the files, because they haven't just been encrypted to your key, they've been encrypted to a secret which is encrypted by your key. And so it's like a wrapper around it. So this lets you add people. It doesn't let you revoke. So you can't say, well, no, I gave him access and I'd like to take it away. Just can't do that. You can move all your files out of that repository and then he can't see them, but he's probably already downloaded them anyway. So I should also mention that this was my first Haskell program, and Haskell's kind of a hard language to learn, and after 2 or 3 years of staring at monads and stuff, you're like, well, maybe I could actually write something that would work now, but it would take forever. And I actually started writing git annex, and I was like, if this were a Perl script, I would have it done tomorrow. And 2 weeks later, I finished it in Haskell. And that was painful, and it was a massive learning experience. But I think it's kind of paid off in the end, as you'll see as we progress a little bit further. Because if it had been written in Perl, it would have ended right here. This would be pretty much all you have, and it would probably be pretty flaky, and I probably wouldn't have be standing up here giving a talk about it, because I wouldn't really have that much confidence in it. So this is the overview of the basic git annex command. But then, after I had been working on this for 1.5 years or something like that, I started getting requests from people who wanted something more. they would say, you know, it's great that I can move these files around and say git annex get a file that I want, and it goes off and finds it somewhere and pulls it down, but it's all manual, and you know, my mom obviously can't use it. You know, heck, I can't use it some of the time because setting up a branch and pushing stuff, and it's Git, it's hard, right? So, you know, for a while I was like, well, I'll add some kind of an auto switch and maybe it'll figure out something a little bit more, or I'll try to, you know, balance whatever, blah, blah, blah. Couldn't figure out what to do and thought about it for a good while. And eventually I came up with an idea, but I was like, this is a bigger idea than the original program, and it's gonna take me at least a year to do it. And I mean a year of like head down, work, 12-hour days. You know, I think I've worked through 260 days of, is that right? 280 days of the past year, yeah. So I said, well, let's fund this thing with a Kickstarter so I actually can put food on the table while I'm doing it. But I actually said, let's fund 3 months, because this Kickstarter for free software, come on, it's not gonna happen. So I put together the best video I could, which was pretty much crap. And I posted it, and I said, well, you know, maybe fund me for 3 months and I can do a few basic things. I'm gonna make a daemon that watches when you put files in a folder and checks them into Git and does some kind of pushing up, and I'll have some kind of a web interface on it to make it pretty and easy to use. You know, something basic like that. And to make it appealing to the kind of people who click through Kickstarter and maybe give $1 here and $1 there, I said, you know, it's probably gonna be something like Dropbox. That's an idea to get your mind around what I'm doing, although something like, you know. So I built that. I should say that the Kickstarter campaign was really successful by modest standards. I got my initial goal within the first day of 3 months, and then within the rest of the, whatever it was, couple of weeks, I got the full year of funding. But I should say that I live in a cabin in the woods and my rent is minimal. My electricity bill is 0 because I have solar panels. You know, I have a very modest lifestyle. So I did build this thing. This is a little screenshot of the web app. This is running as a local server on your computer, which then shows up in your browser. And it's using Twitter Bootstrap, or just Bootstrap as it's called now, which is kind of nice because it gives you the responsive UI. So you have, you know, cell phone-ish friendly stuff without having to go out and spend a lot of time fiddling around with Java and, you know, nastiness, and making an entirely new program just to work on cell phones because they're all different and special, even though they just run Linux, right? So I went off and did that. And of course, the first stage was just getting iNotify to work. And if you haven't used iNotify, it's a bit of a bear, especially when you want to recursively watch a whole directory tree and find all the files that change. So iNotify just finds files, I get events, I try to commit them as quickly as I can, but also detect if you're making a massive batch change, like untouring a tarball or something, and I just make one commit if I can. Of course, it's heuristical. The other neat thing that I realized I could use iNotify for, though, is I can detect pushes coming into my repository. So that kind of lets you use it in a more peer-to-peer way, where somebody else pushes to your laptop, and then it just automatically merges things. And so, of course, that means that you have to somehow deal with the merge. And this is fun. Normally when you're using Git with code, and you get a merge conflict, you have two branches coming in, and there's a file that's different, and you just get conflict markers, and you have to go off and tear your hair out for a while and edit things, and you get something that works, and you can compile it, and you can test it. But when you're dealing with big, large files and you get a merge, what do? All that I could come up with is you have two files now. You have this version of the file, you have that version of the file. I'm not going to try to reconcile them. You can figure that out yourself. They'll have unique names, and that's the best I can do. But luckily, this really doesn't come up that often unless you're heavily editing files and you have lots of people doing it and you don't have any process. And so, in my experience, most of the users of this really don't edit their files a lot. They just add lots more files and maybe move them around and make another version inside their directory, because that's what people are used to doing, and that's fine. So, You have these two machines, maybe it's a laptop and a tablet, maybe it's something else. Let's say they're in the same room. Now, Dropbox has some kind of a local sync-ish thing. I'm not sure if it has to go up to a server and then back down just to figure out what to do between these two machines in the same room. What I came up with is this local pairing system between the two machines. And it starts out by entering a secret phrase on one of the computers and saying, I'd like to start pairing with another computer nearby. Goes off on the network, broadcasts a pair request which pops up in your browser like this, and you just say, okay, yeah, I know that guy. He just said, I would like to share files with you. And you go enter the phrase that he told you. And then you get all the SSH stuff automatically configured. And so this is just using SSH, but what it does is I have this git annex shell program, which becomes the login shell for a specific SSH key. And it verifies the key using the secret phrase, makes sure that the right computers are talking to each other. This protocol has not been vetted by cryptography experts, so yeah, yet. And it goes and sets everything up. Completely, as far as I know, secure. The guy that you're pairing with cannot log into your computer and look at your other files. He can only send files, get files, delete files that are in the repository. So that's great, but what if you have two computers that aren't in the same room and you'd like to share files between them? Well, this gets a lot more hairy. And eventually what I came up with did involve XMPP, because you have to find a way to discover if your friends are using git annex and, figure out who they are and connect together. And I should say that my mom actually is using git annex now. The screenshot and most of the screenshots in this thing are out of date. Yeah. So the way this works is pretty simple. You just tell it, your Jabber address, wherever that happens to be. Maybe it's at Google. Maybe Google doesn't support Jabber anymore. I don't know. And you go through a process similar to the other pairing process, but without the password, because you already know that your friend is your friend on Jabber. And so once that's set up, we can do git push over XMPP. Yeah, it's fun. This was probably the craziest technical thing that I did, and getting the actual push to work wasn't too hard, but getting all the other XMPP crap to work was horrific and a nightmare, and yeah, especially because you want it to work with every server out there, which means you can't rely on any of the crazy protocol extensions that nobody supports, or maybe you could go off and write to Google's, but then Google's gonna can it, whoops. So I use plain XMPP, and I abuse it in various ways that are vaguely protocol compliant. And it's basically just a pipeline, right? You have, normally when you do a git push to someplace like GitHub, they're running something like git receive pack, and it just pipes the data over SSH or over HTTP or whatever it is. And I just throw myself in the middle and translate between bytes and XML. And of course that means you have to base 64 encode your payload, which means that you get a 30-something% increase of the size of the data that you're pushing over XMPP. So this means that it's not actually very appropriate for transferring large files, and I haven't actually bothered to implement that, although maybe somebody will come and say, well, I'd sort of like to shove my large files over XMPP. Fine, I don't care, but at the moment what this is for syncing your metadata around. That's what your Git repository basically is with git annex now. It's not your data, it's your metadata. And so all you have to do is tell another computer, hey, I've got a new file. And that's what XMPP is all about. It's notification, it's pushes, push notification. So once you've done that, you have to have a way to sync your data around. And this is where transfer remotes come in. Now these are basically the same kind of thing that I showed you before, except in a pretty web interface with actual names of hosting providers that you can click on and set things up by entering, a few relevant details. I threw in the archive ones on this slide just to show you that we have other configuration for other kinds of remotes too, not just transfer remotes, which are up there. And all the transfer remote does is it sits there, and you occasionally shove a file up to it, and then another client comes and downloads the file, and then both clients are like, oh, we both got a file, let's delete it. And so you don't need to store a lot of data on these things. I think Box.com comes with a free account that's got like 5 gigabytes or something, but that's plenty. As long as your files are smaller than 5 gigabytes, you can sync them through it. Or you can pay for something that actually is a little bit more professional and reliable, or you can run your own server and just put a repository in it and blast stuff up and down by SSH. Okay, so this is kind of a hairy part of the talk, and you can feel free to zone out, but I came up with this. I was like, well, how am I going to figure out how to control these transfer remotes, right? It's kind of a hairy problem because you want to send files to different repositories and you have to coordinate all this somehow, and it's a distributed network and it's ad hoc and you probably don't even know what the network looks like and it might change from moment to moment. And I eventually came up with this preferred content expression thing, which is basically an embedded domain-specific language built into git annex. It looks kind of like this, and don't worry about what that means much. I think this is the expression for a backup repository. It just tells it which files it wants to have in it. And this has turned out to be really useful. We have all kinds of different little pre-canned expressions. You can say, oh, this thing's a source of files. It's some kind of a camera or something. Files will appear here and they'll be sent off somewhere else and they'll be deleted. You can say, oh, we've got an archive of files. We have a transfer repository, things like that. Putting that little DSL in was a great idea. I'm really happy I did it. Okay, this is where it really gets annoying. I have these wonderful symlinks. I have them in Git. Everything's great until people using Mac come to me and say, you know, our file browser looks all weird, and when we try to edit the file, it's editing something with a file name that looks like long hexadecimal string dot something. And this doesn't seem right. What are you doing to my poor computer? And it turns out that Macs and also 2 or 3 programs on Linux think that symlink means, oh, this is a symlink. It's not just a file that you can access like any other file. You have to go resolve the symlink, and if it points to something, you'll resolve that, and then you'll figure out what that file is, and that's the actual file they wanted you to edit, and that's the name. It's insane. These people do not understand Unix. So I got to do this fun, which was, took my entire symlink beauty and just turned it on its head and said, okay, great. We're going to have regular files in a directory, just like you normally have with Git. We'll have all these symlinks under the hood, because that's the only way you can possibly do it. But everything on top of that will just deal with it and move the files around and deal with all the nastiness inherent in doing that. So when I had to do this, I was really sad because I'd thrown out the core beauty of my idea in a way and gotten rid of the main invariant that made it all sane to write and easy to make sure that it was consistent and that I didn't have any bugs. And then I got all kinds of wonderful bugs, and I spent months dealing with them. But I eventually got it to work fairly well. So, of course, I didn't just need direct mode for Macs and for, what is it? Oh, I don't know, some ebook reader on Linux. No, I needed direct mode because people still use the FAT file system in 2013. Why? I don't know. We've had symlinks since when? 1981 or something? And yet, here we are with the FAT file system. And Git supports the FAT file, yes?
Windows systems or Linux users are actually using FAT systems?
Well, what does your digital camera use? What does your Android phone use for an SD card reader? The question was, are Linux systems using FAT? And yeah, they are. What does your Android tablet use for the SD card? It's probably either a FAT file system or some kind of a crazy user mode, not user mode Linux, but user file system thing that probably doesn't know what symlinks permissions or basically anything is. It may not be able to let you move a file. It's insane. And so yeah, I needed this for Android. I needed this for various things like that. I actually had promised a Windows port. I obviously needed that I needed it for that. Well, Windows FAT. They're basically equivalent still. And yeah, I'd have the OS X port also. I have a Linux port. This has all been a lot of fun to get working. Android has been by far the most fun to get working because basically I have a Haskell program and I want to run it on Android and nobody has ever done that before, So the last time I gave this talk in January, I stood up and said, so I'm getting ready to port to Android and I have no idea if that's even possible. And then 2 weeks later, a port of the Haskell compiler for Android just landed in my lap. It had all been happening under the scenes. I was, oh, thank goodness. Yeah, and but of course it was still an extreme amount of fun to get it all bootstrapped and working. And yes, another question.
Was it a cross-compiler, or did you actually?
It's a cross compiler. I've actually run it natively, but you don't want to. And the other problem is I depend on all kinds of standard Unix tools. Git, not JGit or something. Git. SSH, rsync, GPG. You need these things to use git annex because they're modular tools that it's built on. And they're not available for Android, or if they are, you can download this app, and they can't even talk to each other. And it's a nightmare. So I ended up having basically my own little mini Linux distribution for Android in an app, which unpacks a tarball, and then you get a basic complete Unix system with BusyBox, because Android's BusyBox-ish, whatever it is broken, and you get your whole Linux system, including a terminal emulator, and yeah. Huh?
How much memory does that take?
Unpacked, I believe it's around 50 megs. It's an embedded system. I've done embedded systems for years. It's, and yeah, I think it's probably one of the better just general purpose Android systems now, in my opinion. Maybe yours will vary, but I had to put all that in just to make it work. So yeah, all this porting was fun. Linux wasn't without fun either, because you still have no common package format, and so I have to somehow make it work on every distribution. So I end up with a tarball with every library in the world in it, and a license file that would reach from here to that door if printed out in a 10-point font, and please fix that, somebody. So this is kind of an overview of where we're at right now. This is my family's personal git annex. I was just over at the beach, and so I came back, with the tropical storm hot on my heels, and uploaded some pictures. This is a screenshot from the other day up in the hotel room, just syncing up stuff so my mom can look at the pictures before I get home. It all just works. Yeah, that's basically the UI as it stands now, and at this point, I've spent a year working on it, basically to the day today. Everything works fairly well. There's a lot of to-dos, of course, but it's basically ready for people to run out and use it. If I haven't convinced you that I have enough pieces, because I've only talked about a few things, there's all kinds of other stuff I haven't talked about. This talk is just scratching the surface. And so that's kind of the overview, and I thought I would blast through it fairly quickly. I'm not sure how long that took, but I'm guessing about 20 minutes, and see if you all have any questions. I can go into details on any of this stuff. So go ahead, fire away.
I'm very interested in using something like this for, we have some really large test files, and we don't want to put them in the local Git repo. So what are the steps I have to go through to use
Okay, so the question is, he has some large test files that he, I guess, doesn't want to check into Git, and he wants to know what are the steps to use it. Right. So I don't know if you need the whole git annex assistant. It sounds to me like you just need the git annex command line tool, probably. Unless you have engineers who you don't want to teach how to learn Git or something dealing with these things. Maybe you do. And if you do, the git annex assistant can be used interchangeably with the git annex command line tool. It's just another repository. If you run the assistant in it, then wham, they have automatic syncing and all that stuff, and people who want to use the command line, like me, when I'm normally dealing with my family's repository, it doesn't look like that pretty picture a minute ago. It looks like command line, typey, and then they see pretty. So, so I think that your steps are download, install, make a Git repository, run git annex init, which is a separate step after git init that tells it this is a git annex repository. If I fat finger and type git annex, add everything, I actually do want to add everything and not just, wipe out my source code or something.
So if you do git annex init, it's
yeah.
the whole Git repo?
The whole Git repo is, yes. Now you can do a mixed repo. This is something that we've come up with recently, and it uses a variant on the DSL that I showed. And you can say, these files, like star.c, for example, get checked into Git, and these files get checked into Git annex, say files larger than 1 megabyte. And then the git annex assistant at least will go and say, okay, I know what to do.
Actually, you can have a separate one for just the annex.
Yeah.
Right?
Okay. I think a separate repository for the annex is often the way to go, but there are people who want to do, say, game development or something, and they need to have their assets for the game and their code together, or they would certainly like to, and so, it's useful that way. So once you get the basic repository set up, everything from that point is going to be just like using normal Git, except you have to arrange for a way to send the actual data. Now, if you have a server, say a company server, then that everybody already has a login on, then it's trivial. They can all just push data to the central Git repository, just like they would normally get pushed to it. And it stores it in .git. Okay, it's a bare Git repository, so it's foo.git/annex/object, basically. And so that's the simple centralized model with git annex. You can also do distributed models where you're off in the hall, sending data between laptops or whatever.
When you add a file, how do you tell it where the file is?
When you add a file, how do you tell it where the file is?
Because you're
Okay.
writing it's actually somewhere else, right?
When you start off by adding a file, it's always local to you. You have the file on a computer in a repository, just like you would if you were checking a new file into Git. You've edited hello.c, or you've spat out hello.mygenome is this. You just say git add or git annex add that file, and then it's checked into the repository. It's still local in your repository at that point. Git annex does local storage. So you always have a local copy of whatever files you've told it you want to have, or whatever. You may not have all the files in the repository, all the files in the history, although they are retained unless you tell it, I actually checked in this enormous thing and that was illegal, or I didn't want it, or whatever. Please nuke it now, which you can do with git annex, quite a lot easier than with Git, but it's still got a lot of safety features that you have to go through to delete data. But normally, you have files in your local repository, files in your remote repositories, and it moves them around between them and keeps track of what's where.
So, I'm sorry.
And let me, before there are more questions, I should mention that since I have got it working on Android, I can actually show you that. Look, it's working on Android. I can go farther than that, though. I can let you guys, if this thing will turn back on. I can pass this thing around and let you play with it if you'd like to. I don't know if there's anybody in this room who doesn't want to have something other than the back of their head photographed. And for some reason, I can't even use my Android tablet right now. Come on, turn on. No, really, turn on. This is the cheapest Android tablet you can buy on Amazon at the moment. It came pre-rooted, but you don't need to root it to run git annex. You just download an app and install it. Anyway, yeah. So if somebody would like to take a picture with this thing, just like you would with any other Android tablet, it'll automatically get synced over to my laptop and pushed up to some website somewhere, and who knows what will happen to it. Any takers? No? Yeah, let's take some pictures. I can actually show you that happening over here. Oh, are you taking a picture of me?
Yeah, that's not what I wanted.
So this is the web app starting up in my temporary repository that, just for cruft. And it's going off and syncing with stuff and things like that. But once he takes the picture, assuming that there's a Wi-Fi network in here, which I can't really guarantee at the moment, and within a minute or whatever, it takes it to SSH from here to here on this network, you'll see the picture pop up and be transferred. See, right there it goes. It's already actually been uploaded, I think, if that's the right one. Anyway, it's syncing stuff between these devices. This thing it doesn't keep a copy of everything, it just uploads it and then deletes it, because that's how I set it up. You could set up crazy things like, for example, random phone that lies around, you take a picture and it gets uploaded to archive.org or to your news organization or whatever, it gets encrypted in transit. You can do all kinds of wacky stuff.
So how did that happen without doing a git add and git commit?
Well, because I have an iNotify daemon running here that's watching on Android for files to show up in the media DCIM directory. I said, oh, here's a picture, wham, uploaded it. My laptop was like, okay, here's a picture. And it went on and uploaded it to my website. Let's see, I think I have to.
Is that built in, or do you just say?
The uploading to the website is, and I don't think this is actually the same picture, so I don't think the network is working, but here's one I took earlier today. Wow, they work. All this is how I configured this particular repository and this repository. It's not the default behavior at all. It's just what, I happen to come up with right now. So I don't know if there are any other questions. Anybody?
Well, if nobody else has, I haven't heard.
Yeah, feel free.
So I'm setting this up. I do a git annex init. I have the local file. I add it, I commit it, I push it.
Yep.
And then what do other users see?
Right. Okay. If you've committed and you've just pushed git, and you haven't actually copied the file anywhere. Okay, the question was, he's added a file, and he commits it, and he pushes it. What happened? What do other people using this repository, other clones, see? So if you've only pushed the git history, or if you've only pushed git, you've committed, you've pushed, just like you normally would, your normal workflow with git, then they'll pull, just like their normal workflow is, and they'll see a broken symbol, and they'll say, where's this file that you've added? And they'll probably type git annex where is file, and they'll say, oh, it's on your name's laptop, because it keeps track of these things.
So it's not copied to a central place?
It doesn't automatically copy to a central place. Now, the git annex assistant generally does copy to a central place because it's all automated. But the command line tool is simple. You'd have to tell it git annex copy to origin or something like that. And then they'll have a copy. They can git annex get it, and they have their file.
And how do versions work? If they're text files, it's just a disk stored?
Okay, how do versions work? That's a great question because a lot of people get confused about git annex and think, oh, it doesn't actually track versions. It somehow bypasses Git's version tracking entirely, and I'm only using it for the files that I have now. That's not the case. You can have branches, you can have versions, you can go back in time and look at what your old files were. All the stuff you could normally do with Git, because you're tracking the symlinks with Git, so you can obviously go check them out. And once you have, it's pointing off to it's pointing off to the key of the hash of the file. And as long as you haven't deleted that or lost it somehow, you can still access it.
But it's storing the files in their entirety? Or?
Okay, yes. So this is also a good question. Yes, is it stored in the file system in its entirety? If you have version A of a file, you make a 1 byte change to it, and it's a 300 megabyte file, do you now have 600 megabytes? And yes, you do. Git has packing. Git actually started out with the same thing, if you remember. And I actually looked at Git and I was like, gosh, it doesn't even bother to like do something with the files to make them not be enormous when you have a million versions of one file. That can't possibly take off. And I went off and ignored it for 2 years. That was bright. But I haven't tried to deal with the problem because it's a bit more complicated. You need to do some kind of delta-ing. So at the moment, I assume that your drive space is quite cheap somewhere, maybe not the drive space on your netbook, that's fine. You can have a tiny little drive and send all the files off to the big server where they're archived away and kept, and then you can pull them down when you need them. But yeah, we keep a copy of every file. The first optimization I'm going to do is making it use the old version as a basis for the rsync of the new version because bandwidth isn't cheap. But I haven't done that yet. So anybody else?
So I'm just trying to clear this in my head. So you do the git annex copy and it's at that central place. And then the other user, if they do a git pull, do they see the symlink with that location?
Indeed they do. What they see, I can show you. It might help to actually get a little more concrete here and do the command line stuff because, can you all see that okay in the back? Okay, so, oh, thank you. Yeah, I can't see my screen here. Okay, I have to do the git annex in it. You know, you have to make a file. I'm just gonna make a small file. Kind of stupid, but. Okay, so we have a file. It's checked in. You can see it's a symlink. That's how the actual symlink looks. We have a SHA-256. If it was foo dot, you know. You can also just skip telling it what file it is. It does it with everything, generally, which I find useful. So it puts a ping extension on because lots of programs that are crazy and look at symlinks again. So at this point, I've made some files. I haven't even committed them. And then if I commit them, here's all I've committed, 2 symlinks. So the actual content is, over here in .git annex objects, blah, blah, blah. So yeah, it's metadata and data. And if I then go Okay. It knows where they are. If you're wondering how this works, there's all kinds of crazy stuff going on under the hood with another branch called the git annex branch, which keeps track of metadata, of additional metadata about your files, like where they are and where they used to be and some configuration things and stuff, and is automatically moved around and merged behind your back. So I can say, pull down the files. It just used copy for this because it's local, of course. If it were over the network, it would use SSH and rsync by default, or whatever your Git remote is configured to use, really.
So, but those things are to your machine. If someone else is on another machine, what do they see?
Same thing.
So like to their machine?
Okay. Yeah, he's asking what do they see if they're on a different machine and they have this other clone. They see basically what I've showed you here. The only difference is that when they go and get the file, they have to connect to my machine to get it, because it was on my machine. Or they have to connect to wherever the file ended up. Let me show you some actual live data. If I can think of something that I would like to show you. So you can see I have a file that's there. These are some podcasts I listen to occasionally. I can query it and ask it where all my files happen to be. They're spread out in various places. I like to tell git annex to keep 5 copies of every sound file that I own. Random podcasts that I haven't quite gotten around to getting 5 copies of, I have 4. And you know, it knows where it is and it can go try it. If I ask it for one of the files, it'll say, okay, I'm gonna try stick, which happens to be my computer at home. It doesn't know where I am. And it's like, okay, I'll try turtle, which is a slow computer off somewhere on the network, and bam, it gets the file. So, you know, you don't really have to think about where your files are with git annex. You just have to think about whether you want them to be local or you want them to go away.
So it can be used as a peer-to-peer system without any server.
It can totally be used as a peer-to-peer system without any server at all, yes. It's just as distributed as Git. There are a few other things that do things like this with Git. There's something called Git Media that is a centralized system, I believe. As far as I know, I'm the only completely peer-to-peer large file handling thing with Git. And how are we doing on time? We have about 10 or 15 minutes. 10 minutes, all right. And we may have no more questions, that's fine. Or if somebody would like to ask me about something weird like Haskell and Android, or you know, whatever, I'm happy to ramble.
See some of the Haskell code?
Oh yeah, sure, you can see some of the Haskell code, but I don't know if I want to make everybody flee the room right now.
What did you write annex in?
Huh?
What language you write in?
I wrote it in Haskell. This is actually, I talked to Haskell people and I'm like, I have a 25,000 line Haskell program. I'm like, wow, that's a lot of Haskell. Then they're probably like, couldn't you make that like 10 times smaller by using this incredibly complicated thing you need a PhD in computer science and 15 years of math to understand? I'm like, well, probably. Right. So let me think of some interesting code to show you. I don't know. Pick a file, any file. I don't care.
Git.Haskell.
Huh?
Git.Haskell.
Where's the? Oh, okay. Yeah, git.hs. Probably not a good example because it's one of the first files I wrote, but yeah. You know, Haskell functions, nothing particularly interesting. Pure code. Nothing in here even uses I/O except for this last one, so everything else can be automatically tested and has some kind of good type system doing sanity checks behind my back and stuff, which is the kind of thing that I like Haskell for. I don't know if that really tells you much. Let's go to something more interesting. I have a few different wacky threads for git annex, for the assistant rather, since it's a long-running daemon. Let's look at the watcher. This is probably gonna make you flee screaming. This is some of the harder code to get right because it's highly, well, you have all kinds of stuff happening in your file system and you get events a little bit delayed and the file might not be there anymore, and you know, you're trying to keep up with all these events and do something sane, and it gets complicated and there's all kinds of race conditions and it's a lot of fun. So this is not some of the prettier Haskell code you'll ever see. This is probably some of the worst Haskell code you'll ever see. But Why did I write it in Haskell? Well, first of all, it was my first Haskell program, and it seemed like a good idea at the time. I'd heard a lot of good things about Haskell and read up on it, and I really needed to start doing something with it. And like I said earlier, I probably would have ended up with a, 120-line Perl script or something and said, oh, this is good enough, and that would be fine. But then if I had said, well, I'd like to do this daemon and all this stuff, I probably would have thrown out the 120-line Perl script and said, well, either I'm not going to do it because that's insane, or rewrite or something. So I really think that starting off with the Haskell, even though it was a really annoying learning curve, and I spent days stuck on something that I just couldn't get to compile at all, type errors like you wouldn't believe this long. I eventually ended up with a core that was good enough that it really has sped up my development, and it's let me go places that, like in the heavily concurrent threaded programs, that I never would have gone from a Perl script to. Yeah.
And I'm not questioning your decision about
Yeah. You have to try new things, and you have to stretch yourself every now and then.
Do you feel like Haskell was the right choice now?
Yeah. I would be unhappy using something other than Haskell now, actually. Yeah. I should also mention that, well, whatever. I've written a fair amount of portable Haskell code. It's not all just my own cruft. This is stuff that actually needs to go up on as reusable libraries at some point. So yeah, I've added a few things to the Haskell body of knowledge at this point. Yeah, I don't know if everybody in this room is bored to death of the Haskell stuff or interested in it. I'm happy to ramble on about it forever, really. I guess I could mention that one of the neater things that I'm using where did I go? This is an Inkscape plugin called Sozy. I bet that's a play on Prezi. Yeah. Where'd I go? This web app is, it uses Twitter Bootstrap for the pretty glossy front end, but the back end is all this crazy, insane Haskell stuff called Yasod, which is the most heavily typed Ruby on Rails clone that you could ever imagine. It really wants to be Ruby on Rails, but do everything in an insane way that prevents you from ever making a mistake, including mistyping a URL. And enforces this at the type level. So if you type in the wrong name for your URL, you'll get, no, actually your type only has these other URLs in it. This is not part of the set of valid URLs. It's nuts and it's wonderful, but it's also caused me a lot of pain importing to Android because it uses this thing called template Haskell, which is kind of like Lisp macros, and isn't available for Android. So I had all kinds of fun working around that. Yeah, it's a lot of code generation and stuff. And I think we're probably pretty much out of time now, so thank you all for coming.
When we created Asterisk over a decade ago, we could not have imagined that Asterisk would not only become the most widely adopted open source communication software on the planet, but that it would impact the entire industry in the way that it has. Today, Asterisk has found its way into more than 170 countries and virtually every Fortune 1000 company.
The success of Asterisk has enabled a transition of power from the hands of the traditional proprietary phone vendors into the hands of the users and administrators of phone systems. Using this power, our customers have created all sorts of business-changing applications, from small office phone systems to mission-critical call centers to international carrier networks. In fact, there's even an entire country whose communications infrastructure runs on Asterisk.
Digium has always been about creating technology that expands communications capabilities in ways that we could never have imagined. And that's part of what's game-changing about Digium. Today, we're doing it again, this time by introducing a new family of HD IP phones that extends control of the user all the way to the desktop.
The launch of these new products represents the next phase in Digium's history of innovation. These are the first and only IP phones designed to fully leverage the power of Asterisk. When we first discussed our expectations for building a family of phones for use with Asterisk, our requirements were pretty simple. We asked the team to build the phones such that they were easy to install, integrate, provision, and use. I think you'll soon agree our engineers have delivered on that goal. User feedback is validating that when it comes to operation with Asterisk-based systems, including our own SwitchVox-based product, these are the easiest to use, best integrated, most interoperable products on the market today. The Digium family of phones will initially include 3 IP desk phones, uniquely designed to complement any Asterisk or SwitchVox-based solution. These phones are different for a number of reasons. First, they're exclusively designed for use with Asterisk. Secondly, we've made it really easy to auto-discover and provision the phones. Next, we've made it easy for the phones to access information inside of Asterisk, allowing tight coupling between an application and the phone. Additionally, we've created an applications engine that allows users and developers to create and run their own apps on the phone. And finally, we've done all of this at a very compelling price point. At Digium, we're always thinking of ways to give our customers the best value in business phone systems and also give them the power to create their own solutions for any communications challenge.
We'll continue to push the boundaries, not only to make Asterisk cooler, faster, and more technologically feature-rich, but to make Asterisk and VoIP communications even easier.
And together, we'll change the way the world communicates.
Again.
Cloud stacks are everywhere.
This is the way to better utilize all your resources, and it makes managing all your resources pretty easy.
All of the innovation is happening in open source. The collaborative nature and of the community and the speed at which these deficiencies, these bugs are getting discovered and fixed is a thing that really shows the power of the open source community.
It is global, and it's definitely because of the users.
Community people are extremely friendly and always ready to help.
If you go onto IRC any day, you'll see these guys helping each other out, and they're all doing it like in a selfless manner.
The product is transparent for everyone. Everyone can look at the code base. Everyone can see how CloudStack is being built. Nothing is proprietary. Everything is open.
In many ways, it's absolutely vital to the ongoing health of CloudStack.
The most exciting event in recent memory for me was our first developer boot camp. And our call gave people, I think, maybe 2 weeks notice to come attend. I was expecting 25 or 30 people. So we ended up with 87 people and had to go get more chairs into the room twice.
Everything within cloud computing is commodity and is open source. And so I don't think that you'll see anywhere where open source is not pervasive in cloud computing. And so I think it's an assumption. I think when you talk about cloud computing, you're really talking about open source cloud computing.
CloudStack is a robust solution for large deployments.
You have dozens of data centers and thousands of servers in each data center. Hardware is going to fail, and CloudStack is designed to handle, number one, that mass scale. Number two, it's designed to handle the failure that inevitably happens in large deployments.
We started working on CloudStack over 4 years ago, and it was the original set of people working on it had a background of delivering software to telcos and service providers.
Lots of QA, lots of users actually using it.
High availability is the key feature. Multiple hypervisor support, different network models. You can pick up whatever suits you better.
CloudStack management server can be deployed in different physical machines.
It definitely has a huge footprint. It's being deployed everywhere.
There's a major movie studio that they were using CloudStack. They were using it to transcode video, and I thought that was terribly fascinating. What I found more fascinating is what they did during lunch, where they would spin up 50 or 60 game servers. Then as soon as lunch was over, they would destroy all the instances and go back to doing real work.
CloudStack is vast. It touches so many different aspects, and there's no one person that's kind of like a master of all those realms.
I think CloudStack as a project is going to be one of the leaders, simply because it's some of the most featureful and robust platforms out there.
I don't see any limits to the CloudStack.
Most enterprises today realize that usernames and passwords alone aren't enough to keep their network safe from unauthorized intrusions. That's why two-factor authentication has gotten so popular lately. It adds that extra layer of protection enterprise networks need to stay safe. But what you may not know is that some two-factor authentication solutions, they're better than others, like two-factor strong authentication with Wicked. Wicked goes beyond other authentication systems by being less expensive, easier to implement, and easier to use, giving you software-based token clients built to run on all major devices and OSs, including iOS and Android. These tokens utilize a public-private key combination that's generated on device, so there aren't any shared secrets flying around for attackers to hijack, or which require any special handling. Instead, all keys are kept secure and private between the requesting token and your server, which you control in-house, making it the most secure way possible to perform authentication encryption. And with an extensive, flexible API and support for protocols like LDAP and Radius, Wicked works with any enterprise network architecture to protect the IT systems vital to your enterprise. Download your Wicked free trial today, regardless of whether you're considering two-factor authentication for the first time or just ready to ditch your existing expensive key fob system. We can help with easy-to-implement, easy-to-use, strong authentication. From Wicked.
Your customers rely on your website or application. If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.